So good afternoon, everyone.
Good afternoon.
Okay, thanks so much. So good afternoon, everyone. Today, Andaman Intelligent Tourism and Service Informatics Center, or AI-TASi, and the College of Computing, Queen of Songkran University, Phuket campus. We are very happy to introduce our special lecture by Professor Hitoshi Isahara from Otemon Gakuin University from Japan. In the topics about natural language processing and its social implementation. Professor Isahara, can you hear me now?
Yes.
Okay, so I think while the Professor Isahara sharing his screen, let me introduce the profile, let know our special guest, the special speaker today. Okay, Professor Isahara, could you please try to share your screen right now? Okay, so let me introduce our special speaker. So Professor Hitoshi Isahara. So actually Professor Isahara received his PhD degree in electrical engineering from Tokyo University in Japan in 1995. And then his research interest includes natural language processing, machine translation, and lexical semantics. And right now, he was working at the electrotechnical laboratory of Japanese Ministry of International Trade and Industry from 1980 to 1995, and was working at the Communication Research Laboratory of Japanese Ministry of Post and Telecommunication. Currently, the National Institute of Information and Communication Technology, or NICT, from 1995 to 29, and was working as a professor and the director of the Information and Media Center at Toyohashi University of Technology from 2010 to 2021. And right now, from April 2021, he is working at the Otemon Gakuin University. Okay, Professor, right now I can see your screen. So all the participants, if you have any question, if you like to ask the professor, you can raise your hand in Microsoft, Zoom application, or you can drop the message in this application. And right now, our session, we broadcast to everyone online. So if you have any question from the message, like a Facebook or YouTube, our staff gonna bring those questions to us. Professor, you ready now?
Yeah.
Okay, please start. Thanks so much.
Can you see my slide on the presentation mode?
Yes.
Yes, Professor.
Okay, thank you very much. So first of all, thank you very much for inviting me to this very nice lecture. So today I'd like to talk about natural language processing and its social implementation. So researches which are presented in this talk are partially supported by Knowledge Hub IT project. So
recording in progress.
So it's hosted by IT prefectural government. So firstly, I'll show you the overview of this project, Knowledge Hub IT Priority Research Project. This is a government funding research project, and two universities, my university, Otemon University, and the Toyohashi University of Technology, which is my ex-university, and 6 companies, including Microsoft Japan and other major Japanese companies, and 1 social welfare corporation. This project is a 3-year project. So this fiscal year, 2021, is the last year of this 3-year project. So in this project, we have 3 topics. One is knowledge extraction. We'll extract knowledges from corpus. We'll extract salient terms and phrases from corpus and extract the meaning of such expressions. So this is first part. So the part of this, the research in this part will be presented by Professor Kanzaki next week. And the second term is a machine translation. So we will tune the machine translation system to each industries, and each industry members will use our result. The third one is a conversation systems. Here we have two applications. One is nothing robot. You can see the robot on these screens. This is small, the semi-human sized robot. So this robot can walk inside the hospital and check whether there's some people laying on the floor or something like that. And we are adding some conversationality to this robot. And this robot, this kind of technology will be used in the nursing home and hospitals. And another application of this conversational system is a FAQ retrieval. So this kind of application will be used by the local government. So today I focus on the rather basic technologies in this talk. So firstly, I have a couple of questions and my answer. So first one is, will AI-style machine translation, say neural machine translation system, surpass humans? My answer is, I don't know, because there are no clear definition about surpass. And second question is much more concrete one. So will AI type machine translation system surpass the ability of ordinary humans to translate a single sentence? Here, my answer is very simple, yes. So current neural machine translation system already has this kind of ability. The third question is much short. AI surpass humans. So here, my answer is very clear. It's no. Because we create AI system and we use AI system and we analyze or understand the output of AI systems. So everything can be done by human, not the AI system. So I believe AI will not surpass humans. So I go into the natural language processing part. So natural language processing technology, NLP for short, is computational analysis of language. So the application of this kind of technology is a machine translation, information retrieval, question answering, and conversational systems, and so on. This is a part of artificial intelligence technologies. Recently, many people talk about artificial intelligence. Some of such the reason is that it's for board game like chess or shogi or go. So for such board games, AI system surpass the human champion. They won to the human champion in chess, shogi, and go. Oh, sorry, I don't know whether you know shogi or go, but it's Japanese board game like chess. But for chess, computer can win the world champion of chess in 1988, rather long time ago. But chess is rather simple game. But the Japanese chess, shogi, has a wider board and they have many more more tokens. So people say to make a computer system which win the human champion is very difficult in shogi. But in 2013, machine translation AI system won the human champion, at least a leading player of shogi. So even that time, people says the Go, another Japanese board game, much wider board. So here, Go is very difficult. So it would take some time to make the computer system to win human. But in reality, just 3 years later, in 2016, computer system won the Go champion. So here, what kind of board games are difficult for computers? So we can say the bigger board is a more difficult. And for computer, it is difficult board game which difficult to evaluate the goodness of each action or each move. But this kind of board game is based on the predefined concrete rules. So each move is the possibility is a finite number. Suppose at the beginning in chess, the possibility of your move is say 10 or 20. Then you choose one of them. Then your counterpart will choose one from their possibility, his or her possibilities. So say it's 10 again. So now you have 100 possibilities. Then 1,000 possibilities, 10,000 possibilities. But anyway, it's not infinite, it's finite number. So you can, imaginally, you can make very big trees of all chess game. So of course, even current big machine, big computer cannot handle such big tree. But theoretically, it's possible. So in reality, the problem is how to handle such kind of big trees virtually. So in that case, computer system has to evaluate the goodness of each action, not to see all the trees, but see only the part of the tree and find which one is the best one, which one is better than other ones. So if to choose such things is very difficult, it means such game is difficult for computers. But anyway, everything is based on the predefined concrete rules. So in that sense, AI plays games with different algorithms than humans. So we have very limited computer power in our brains and also limited memory in our brains. So our algorithm is different from computers. So that is one reason that computer win human champion. But natural language processing is very different from such board game processing. Natural language processing is the processing of symbols. For language processing, there are two things. One is the text processing, and the other is the speech processing. Here, I mean natural language processing as text processing. So speech is not a process of symbols, it's a process of signals. So they will have to extract features from symbols. Sorry, it's my mistake. It's features from signals. However, for natural processing, text processing, the task is an extraction of features from symbols or characters or terms, phrases, such things, not signal. So how to understand the meaning is a combination of symbols. We'll extract the meaning from the combination of symbols. But the different thing is that text could be read differently in a different context. So one surface structure can be understood differently in different situations. So there's an ambiguity. So to solve the ambiguity is the main task of natural language processing. So now I would like to talk a little bit about machine translation. Yeah, it's a part of NLP applications and translation and cryptograph. So when digital computer, current computer system born, it's say 70 years ago, around 1950, 1940 to 50. So it's during the World War II. So from that time, people start the research on natural language processing. At that time, during the war, the reason why they created the digital computer is one of the reasons is handle cryptograph. Cryptograph is a conversion system from sentence to nonsensical character string. So if your enemy can get such string, they cannot understand what it means. But your friend has a decoding system from nonsensical character string to actual sentence. So your friend can understand the original sentence. So that's cryptograph. I say that's a nonsensical character string. So it means nonsensical for your enemy. For me, I can understand, of course, Japanese, and I can understand English, but I cannot understand Russian at all. So if someone translates original sentence to Russian sentence, for me, it's a cryptograph. So the sentence to cryptograph and sentence is very similar to translation. Japanese to English and English to Japanese, or Japanese to Russian and Russian to Japanese. So at the beginning of the history of digital computer, people start the research of natural language processing, especially machine translation. So machine translation has a very long history, more than 70 years. However, nobody thinks the machine for cryptograph understand the sentence. So I can say translation system does not understand language. So what is understanding? There is a test named Turing test, which defines what is understanding. Sorry, this picture is in Japanese, but you can imagine. So there's one room, and in the middle of the room, there's one curtain. And the left-hand side is you, and right-hand side, there are two things. One is computer, the other is human. And you can communicate with typewriters. So if you ask several things to counterpart in the right-hand side, and then see the output from the right side. And if you cannot decide which one is computer and which one is human, then that computer system work as human do. So that is the definition of understanding by Turing test. Yeah, maybe it's very reasonable. However, there's another thought named Chinese rule. So it's almost same, very similar situation. Big room, but one curtain here. You can write Chinese character, Chinese sentence. Suppose you are Chinese people, at least you can understand Chinese. So you write some Chinese characters and make Chinese sentence and put that paper to the right-hand side. And in the right-hand side, there's no computer, but a person. But this person does not understand Chinese at all, but he has a very big book of how to handle these papers. So he received a paper from you and find several characters. Oh, in reality, the right-hand side people cannot think this one is a character. Maybe he supposed this is a kind of picture or figure. So checking with his big manual book and find, oh, if first character is this figure, and I write this figure and something like that. Then he make one picture on the paper and send it back to you, that person in left-hand side. So left-hand side people see, oh, this is Chinese sentence. So in that case, the right-hand side people understand Chinese sentence or not. Of course, everybody says, no, right-hand side people does not understand Chinese at all. He just has a manual book to handle Chinese characters. Yeah, but suppose if right-hand side people is very clever and can understand everything written in this big manual book. So everything is done in his brain. He does not consult with such a manual book outside. So in that case, everything is done in his brain. So do you think he understands Chinese or not? Or why you can say he does not understand Chinese? So definition of understanding is very difficult. Anyway, the main task of natural processing is to handle ambiguity. So please see this sentence. This one is very popular in NLP research. So some of you already heard about this sentence, but let's see. So I saw a girl with a telescope. This sentence is very ambiguous. Can you find the ambiguity of this sentence? At least there are 4 interpretations. One is the ambiguity of the verb saw. One meaning of saw is using one's eye to look. And the other is cutting material using a saw. For using one's eyes, in this case, it's a past case. And cutting material using saw is a present case. And another ambiguity is with. The one interpretation is a saw with, and the other interpretation is girl with. So one interpretation is I saw a girl with a telescope. The other interpretation, I saw a girl I saw with a telescope. I saw a girl with a, I saw with a telescope. I saw a girl. So these two ambiguities. And so has two ambiguities. So 2 by 2, it makes a 4 ambiguities. So the task of natural language processing is to disambiguation. So I saw a girl with a telescope. So we can write some information in a dictionary that people cannot cut material using a telescope because we need some shape tools. Normally, the telescope is rather round, so it's very difficult to saw something using telescope. So we can write this kind of information to the dictionary. It's okay. The other way of disambiguation is using common sense. So people normally does not cut the girl using a saw. So that's another possibility. But yeah, in very concrete situation, we can say these two restrictions. However, yeah, we say we cannot cut material using a telescope. So similar thing is, say, for talk or speak, the agent or subject of these talk or speak should be human. Only human can speak. Only human has languages. But in a fairy tale, you can understand the sentence, the stone speaks, or mountain lands, or such things. We can understand such text and imagine some situations that stone can talk or mountain can walk. So our ability to understand the language has such kind of inference. And for common sense, of course, people does not cut girl usually using a saw. But again, you can imagine the situation that, oh, I'm a magician and one of my favorite magic is cutting a human. There's such kind of magics. Then today I saw a girl with a telescope. I cut a girl with telescope. That kind of sentence is possible if I'm a magician. So we can use this kind of restrictions like dictionary representation or common sense. However, we human has the ability to surpass such restrictions. Then it's very difficult to make a natural language processing system which is similar to human do. But anyway, so mainly we use this kind of dictionary representation and common sense to disambiguate the meaning of the sentence. And knowledge or context will be used for disambiguation. Okay, so I showed you that there are 4 ambiguities for I saw a girl with a telescope. So here's a quiz. So how many interpretations? Like time flies like an arrow. Yeah. It's a kind of frequently speak to phrases. So normally we don't think there's an ambiguities. But this sentence is very ambiguous for computer system. So the normal interpretation is the second one. Time, the flies is above. Time flies like an arrow. However, the first one is possible. It's an imperative sentence. Time is above. So please time the speed of flies or something like that. And third interpretation is also possible. Time is noun and flies is noun. So time flies is it's a name of new type of fly. And that kind of new type of fly likes and narrow. So this is another possible ambiguities. So if we have no more information than dictionary or grammar rules, we can't disambiguate these ambiguities. Okay, we'll go to the talk about machine translations. So as I told you that, as I said to you, the machine translation has a very long history, around 70 years. So at the beginning of the research history, we started rule-based machine translation, RBMT for short. So using grammar rules and dictionary. This system is very, it's very useful. It can be tuned to domain and expressions because we write complete grammar and dictionaries. So we add some specific grammars to tune to domain such things. And of course, we have very, very long history of research and development. So they have very huge amount of resources, translation rules and translation dictionaries. However, to make such resources, we need costs. So it means time and money. So to make huge grammar which cover almost all expressions that human can create, or all a very huge dictionaries which stores almost every word in that one people can talk or write. So because of this kind of restrictions like time and money, it is very difficult to achieve high quality translations. So the next step is we start the research on statistical MT, SMT for short. So it utilizes statistical machine learning. So we prepare a very big parallel corpus. Parallel corpus is Japanese and English, and say English and French and so forth. So once we have such huge parallel corpus, this system does not need huge human cost for creating grammar and dictionary. But of course, it requires a large amount of parallel text, which is not available at present. Single language corpus text database is available in most cases. However, parallel data is rather difficult to gather and utilize. And for example, to say English and French is a rather similar language in style. So for machine translation between English and French, then the amount of necessary parallel text is not so huge. Yeah, it's huge, but not so huge. But for example, Japanese and English is very different in style. So in that case, the parallel text needed is very big. And also, there is not so enough amount of parallel text between Japanese and English. And another problem is SMT does not utilize any linguistic knowledge in principle. So sometimes ridiculous translations appear. I said very frequently, but sometimes it appears. So it's a kind of word-to-word replacement. So the quality is output of SMT is not enough. So 5 or 6 years ago, the new system begins, the neural machine translation using neural network or deep learning. So at that time, since 2016, the performance of the machine translation system was greatly improved. So roughly speaking, it's from word-to-word replacement that the SMT does to sentence-to-sentence replacement. So translation output is, people say translation output are comparable to human. We have two axes of evaluation of machine translation. One is fluency and the other is adequacy. Then fluency is almost perfect. So this is very rough sketch of neural translation. So firstly, we prepare parallel text of Japanese, say Japanese and English, and using this Japanese as input, we'll firstly translate using neural network systems. Then we get some translated text. But of course, it has erroneous sentences. And we'll compare with this original input, original English and translated text. And tuning. Tuning is a kind of parameter tuning of these neural networks. So we repeated this process. And finally, we'll get some neural network after training. Then Japanese text can be translated into English using this trained neural network. And there are another things to use deep learning mechanisms. One is extraction of the relations among words. So this is a three-dimensional semantic map which extracts from the several years worth newspaper text. And the other output of this kind of deep learning mechanism is a word-to-vector. So here you can see there's several there's vectors from man to woman. So if we add this vector, man to woman vector, to uncle vector, so the result is ant. And if you add this man to woman vector to king vector, so the result is a queen vector. So you can calculate the relation on semantics using vector calculations. Say, so for example, in the right hand down, so there's if you can create the vector from France to Paris, it means to extract the capital of a country, of a nation. So if you add Italy vector, if you add this capital extracted vector to Italy, so you'll get the output Rome. So it's very interesting result of deep learning. Okay, go back to machine translation. So I will show you how neural machine translation is better than SMT. Sorry, it's a Japanese to English translation, but even if you don't understand Japanese, you can compare the output of SMT and NMT. So this the original sentence is extracted from the web page of local government. So you can see the output of SMT, vulnerable waste is collected in the day of the week, decided twice a week. So it's a little bit difficult to understand. But for NMT, vulnerable garbage is collected twice a week on the designated days of the week. So I think it's very, very understandable. The second one is, please take each 3 bundles out of 2 after the small branch and the leaf are made about 30 centimeters length. Yeah, we can imagine the meaning, but from this sentence only, it's very difficult to understand what we should do for such small leaves. But the NNP is very nice, at least fluent output. Branches and leaves should be about 30 centimeters in length, which put out 2 to 3 bundles each. So SMT, we need some, say, post-editing. We have to edit the output of SMT. But for neural machine translation, maybe we can put the output directly to our web page or such some announcement pages. However, there's a big problem exists. Say this example. Sorry, again, the original sentence is Japanese, but you can see second one is output by SMT, and third one is output by neural machine translation. So even for the second sentence, second text, maybe you can understand something happened in somewhere and traffic is restricted or something. But it is very hard to put this one directly to the web page. The second one looks very nice. A large cliff collapse occurred around 0 o'clock on September 24th at the Kobosa Coast Tunnel, Kamakura side of Zushi, Kobosa 51. For that reason, traffic restrictions are imposed on the Kosugato Coast Tunnel and National Route 134. So it's very fluent output. So we should put it on the web page of some traffic information. Better than nothing, better than only Japanese. However, this output has a big problem. So seeing the Japanese text, you'll see red part, it's same kanji characters, 2 kanji characters, appeared 3 times. The pronunciation of these 2 kanji characters is kotsubo. So SMT output it properly, kotsubo. However, the output of NMT, neural machine translation, is very much erroneous. So first sentence, they translate kotsubo into kobosa. I don't know where this kobosa comes from, but anyway, they translate it to kobosa. And what is worse is they translate this kotsubo into kosugato, different terms in the second sentence. So this text output by neural machine translation is looks very fluent. So people think this is very informative. But in reality, this is not informative. So such proper noun is translate incorrectly and differently in 2 sentences. So here you can see the issues on neural machine translation. So current AI system improve its quality by learning with a large amount of correct data. And process of translation is unclear because everything is done in one neural net. We cannot see the inside process of neural network. So sometimes mistranslation and translation missing. And low frequency word is sometimes translated differently, incorrectly, like a kotsubo and kobosa, kosugato case. So it is because of the limitation of size of vocabulary. So neural machine translation needs a very huge computer power, and that computer power, the necessity of such big computer power comes from the size of the vocabulary. So they limit the size of the vocabulary. So very rare word like kotsubo or kosugato cannot be stored in the dictionary. And sometimes funny repetition occurred in the output. So say if I go to ski and translation of this kind of Japanese sentence, if you I go to ski, 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 such kind of repetition should sometimes happen. Another topic about the neural machine translation is, can we create the control language for neural machine translation? So controlled vocabulary is maybe a good idea because we have the limitation of the size of vocabulary. However, of course, we cannot control the number of proper nouns, or the location names. Control syntax is very difficult. And training by control example, say control language neural machine translation, it may be possible. Actually, I use this example at the beginning of the neural network system. But now, a little bit, the output of this Google translation is now a little bit different. So they improve their system. So the second sentence, the first English, the second text is the text I showed you. And the third text, the bottom text, is the current output of Google translations. So now the term kotsubo, 3 times here, is translated properly kotsubo by Google Translation. They improve their system by which can handle this specific proper noun, location name, kotsubo. However, they still have a problem. They still cannot solve the one problem. So in a first sentence, they say kotsubo coast tunnel. But in the second sentence, they say kotsubo kaigan tunnel. So kaigan is Japanese word, which means a coast. So this second sentence, they use such a kind of named entity here. But in the first sentence, they adopt word-to-word translations. So they still have the problem. And this is the example of how neural machine translation system is a black box system. Okay, this sentence is the second sentence of this example. So this is the original one. You can see this output. So if we change this Japanese term into this Japanese term, it's almost similar. This one is a traffic and this one is a driving. However, when we change this, we add this small change to the input sentence, the structure of the output is completely different. So in this case, traffic on Kotsubo Kaigan Tunnel is restricted. However, in a second sentence, we simply change this word to this word, traffic to driving. So here, there are restrictions on driving. So the structure of these two sentences is very different. And if we eliminate this part means that National Highway number 134. So if we eliminate this part, so here on the Kotsubo Kaigan Tunnel is changed in the Kotsubo Coast Tunnel. we only remove this part from the original text, National Highway number 134. Then the translation output, translation of the proper noun, named entity is changed. So we don't know why this kind of things happened. And we cannot make, we cannot correct this kind of phenomenon. So as I say, currently AI systems improve its quality by learning with a large amount of correct data. So this is another problem. So quality requirement and actual qualities. So when we think about the amount of data, web data is very huge, and industrial document, it's say so-so. But tourism, it's not so many, especially for the parallel text. So the quality of machine translation is like this. So tourism is not so good, industrial so-so, but web data is rather good. So Google or Microsoft system is here. But for quality requirement, web data is for web data, so understandable output is enough. And tourism is, I'm not sure, but for industrial document, requirement is very high because it's a kind of advertise of the industry or some manuals for their material, their products. So they should be 100% perfect translations. But for machine translation system for such industrial document, the quality is not so high. That's a problem. So if we think about the future of machine translation, now current neural machine translation is already better than ordinary people. So, but we still have some errors. So extraction and correction of erroneous translation is one of necessary techniques. And domain adaptation and sentence translation to semantic translation is also a big issue for current neural machine translations. So we use more parallel corpus, and we add some, we should utilize information for individuals. So for low frequency word like kotsubo or such things, we try to the subword unit. So byte pair, sorry, this is another my mistake. Byte pair encoding is a popular technique, and we add the linguistic information to byte pair encoding and creates a better result. So this kind of approach is a good way to solve the low frequency word, to solve the problem of low frequency word. And our challenging target is translation intention. So far, machine translation is sentence translation. And currently, people are trying to create a document translation. Our final target should be not a translation, but a document creation in other languages. I'll show you some example. So this is not machine translation, it's a human translation. Example of human translation. Some of you know the city named Nara. It's a very old capital of Japan. And it's a very touristic city. And Nara city want to gather tourists from all over the world. So they pay attention, pay money to such things. So they have different translations, different document for different countries, different nations. This is for Canada, Canadian people. This is for Canadian people. So left-hand side bottom, you'll see the big trees. So it says Canadian yellow cedar reproduces the essence of Japanese culture. So some old buildings is renovated by using Canadian tree. So makes it interesting for Canadian people. Another example, Nara and United Kingdom. So in this case, left-hand side down, there's a Nara Hotel. So it says Nara Hotel. So several British imperial family stay this hotel, and you can stay this hotel as a imperial family or something like that. So they make this kind of translations, which is tuned to peoples in each countries. And another topic is error detection and corrections. So we have we tried this kind of crowdsourcing post-edit. So still machine translation is not perfect. So some Japanese article is translated into English and post-editing by volunteer and makes fluent Englishes. So we tried this at the Rugby World Cup last year. So in that case, there are many rugby articles dispatched from Japan. And in Japan, there are many rugby fans, senior rugby fans. They have time and they have a will to support foreigners. So such volunteer would post-edit the output of machine translation systems. We create this kind of mechanism. Okay, so leaving from machine translation, I'd like to talk about the language and AI, artificial intelligence or computer. Computer is very high performance, but it's not comparable to human in language processing and mental processing. Our brain is rather limited in computational power and in the size of storage. But we can understand or we can create language better than computers. So we cannot imagine the computer which is superior to human in communications. So this is similar to board game. So humans and computers use different methods for language processing. When we read a sentence, we human by brain, we don't use, say, 40 hours newspaper articles or something like that. We have very limited knowledge. Why? So probably this is because language was created by human brain in real world circumstances in a long history of human creature. So the current language in maybe any language, Japanese, English, Thai, any language, is created by based on human brain, based on the structure of human brain. So if we think like that, so maybe one problem comes from the difference between first language acquisition and second language acquisitions. as I told you, at the beginning of machine translation research, we utilize the rule-based machine translation systems. So we put grammar rule and dictionaries to machine translation system. But it's not a way that we learn our first language or our mother tongue. It's a second language acquisition. When we go to the high school and learn English, then we use dictionary and grammar. So computer should learn language from environment and examples. Or we can say we should create the system which simulates the intelligent processing of human, natural language processing of human. So as I told you, current system, not only neural machine translation, but almost all AI system is depend on deep learning mechanisms, so which needs large amount of correct data. But deep learning or neural net is a very black box between input and output. So we don't know the reason why this AI system output this result. So what we need is not a black box AI system, but AI system with accountabilities. So in that case, the algorithm and data and annotation should be focused on. Last time, to create a system, create a product is rather simple. Firstly, we get data and check the data and analyze the data. And we create the algorithm which can handle such data and implement it by programming it by using program languages. And then put it in the product. So our responsibility is our algorithm correct? Our programming is correct? That's our responsibility. However, current AI system is based on the deep learning. So first, we get data. And then we annotated it. And using this annotated data, we train the neural networks. Then we put it in our product. Of course, such a neural network system, neural network tools, which is available now, is not erroneous, we believe. But the problem is data is okay for our needs and annotation is correct or proper, such things. So our responsibility is moved from algorithm and implement to the data gathering and annotations. And that kind of things is very hard to find the erroneous part. So for annotation, if there may be some, of course, there's no perfect annotation. So there are several errors, several or many errors. Or what is worse is intentioned annotations. Says the right hand top, if somebody annotated this picture as a pen, or left hand side down, if somebody adds this part as a crosswalk, and right hand side down, all these cards as person. So it could make AI system trained by this kind of annotation, ill-intentioned annotation data is very bad. Suppose in the airport, you have the X-ray check system for passengers' baggage. So if the system is trained by this knife is pen data, so even if some bad guy has a knife in his bag, so the system outputted, oh, this is pen, so no problem, or something like that. So annotation is very big problem for current black box system, black box deep learning system. And also data itself is very important, data credibility. So what is the source of data? Is it correct? And also, is this proper? So suppose if we handle the daily conversations and we use the data like as newspaper articles, so it's not proper. We need more oral data, oral speech data, so such things. So is the data source is okay or not? And also comprehensiveness is important. And a little bit different viewpoint is that copyright is a big problem for big data. And as I told you in the previous slide, annotation is very big issues. So to create a proper rule or proper annotation system is very important. And also to maintain the accuracy is a very important thing. Annotation is done by not only single person, but by several persons. So to maintain the accuracy among them is a very big issue, I guess. So data is very important. And so one entity cannot gather big data enough for machine learning. So data sharing is a key word of the future AI system. So data sharing, especially at least for text data, is successful in Europe and the US. For example, TAUS, the organization named TAUS exists. So many huge industries join this TAUS and they put their corpus to the TAUS platform and they can download the corpus from other industries. So this kind of business model is already exist in Europe. TAUS is located in Netherlands. But I don't know the situation of Thailand, but industries in Japan tend to hesitate to share their resources with their competitors in business. So probably Toyota automobile company does not want to share their resources with other automobile companies in Japan, like Nissan or Honda or so forth. Of course, they are competitors. But even with companies in different areas, from them, they hesitate to share their resources. So we have to say, train such companies that to share makes them make it a very win-win relations. So we established the organization named AI Data Consortiums. So the web page says there are many issues to be solved in AI research, open innovation and solution, such as fragmented data providers, different license concept, personal information, and binding with computer resources, and standardization and of contract process and construction of data sharing platform for data provision and utilization. So copyright is handled in this part, and realization of data utilization model, considering personal information and privacy, and realizing a sustainable data utilization platform by realizing various data stores and data commerce. So firstly, there's a data, and using this data, people do the AI research, mainly in university or research organizations. And this accelerates open innovations. Then the output of these kind of things is used in a real business, so accelerates the business and resolve social issues. And by this, they will make more data will be created, and then they use new data for AI research and so forth. This kind of sustainability should be very important. We call it, this organization, AI Data Consortium. Now we have 4 themes, or we have 4 working groups under AI Data Consortium. One is IP and contract. All copyright things as a contract things will be handled here. Then AI research, they are trying to find several ways to use data for AI researches, and data collection, data gathering, and also this data collection includes not only data collection, but data distributions. So actually, I'm chair of this data collection working group. And data platform, it's a computer system, so which can store data and distribute such data and create a contract forms, such things is done by this data platform. Okay, now I'm reaching to the end of my talk. And another problem of AI is ethical dilemma of self-driving cars. So say it's called the Trocco example. You may have heard about it. So if such self-driving car is moving on the road, and it finds several people standing on the road. So if this self-driving car goes straight, that car will hit such 5 people. But if this self-driving cars turn to the right, these 5 people will be okay. But if you turn to the right-hand side, another person is standing there. So to turn to the right is good or not? 5 people and 1 people. So first should be given priorities. Just simply the number of the person or age, rich or poor or whatever. So that kind of things is called the ethical dilemma. Not only self-driving cars, but currently self-driving cars is now very much becoming very, very popular, will be popular. So this ethical dilemma of self-driving car is discussed in several occasions. But so far, such scene has existed. Not self-driving cars, but human driving cars. They find something, he or she finds something, and he just goes straight, or he turns to the right, or so forth. Such scenes have existed. There are many traffic accidents. But in that case, what decide is who decide it is human judgment. And evaluation is done after the incident, after the accident by court. So he is guilty. The court says, oh, you are guilty, you are not guilty, and so forth. So it's ex post evaluation. But for AI or self-driving cars, the car will go straight or turn to the right is fixed in advance. So is it okay to make this kind of self-driving cars on the road? Is it okay or not? So that's a very big problem. We need some philosophy. But another viewpoint exists, I think. Self-driving car, it's okay. Because road maintenance and better driving system, by road maintenance and better driving system, we can make the possibility of this kind of ethical dilemma as low as possible. Every road is overpass or underpass, no crossroad, no no junction, and so forth. And also that such self-driving car runs always under 30 kilometers per hour or so forth. If we create such kind of situations, the problem of self-driving is less and less. However, machine translation to create such situations is very difficult. There are very different intention, different context, different situation. So for machine translation, this kind of ethical dilemma is much severe things, I think. Suppose we have a Julius machine translation system in code. So without machine translation, so people who can talk in the local language should be arrested in prison. But with machine translation system, they will be released. But one unguilty person should be treated as guilty. So in that sense, is okay or not? That's a very philosophical thing. And machine translation cannot be perfect. Yeah, self-driving is rather similar to board game. So because they have rules. So under this speed, or you should stop here, or whatever. But machine translation or language processing. So the creation of the language is by human. So we cannot control the creation of language by human. So this kind of problem is much severe for natural language processing. So one more thing is about data science. So AI system or data science system, we use knowledge extract from data. So we have this kind of language, this kind of sentence. So we extract some co-occurrence relations from this sentence or whatever, something like that. But we have to think about is another kind of knowledge. So it's a knowledge extract from the fact that there is no data. Sometimes people say that dog bite a man is not news, man bite a dog is news. So there is a news or not a news is an existence of that fact or not fact is not related. Shaving at barber shop is my favorite example. When we go to the barber shop and the person in the barber shop come to me with knife to shave my beard, it's okay. But normally, if I'm alone in a small room and some man coming to me with knife, then I should run away. But in a barber shop, it's not necessary for me to run away. But maybe there's no information that in barber shop, if the shop person will come to you with knife, it's okay. There's no such information. But there's no news which in a barber shop, the person in the shop person will kill the customer with knife or something like that. So there's a knowledge extracted from the fact that there is no data. So not only the knowledge extraction from data, but also the knowledge extracted from the fact that there's no data is very important, I think. We understand and we use such knowledge for our daily life. Okay, that's all. Thank you very much.
Thank you so much, Professor Isahara. So right now, our participants, if you have any questions or comments, could you please provide in the Zoom's chat? And right now, I got some questions and then feedback from the participants. Let me ask the first one, okay? The first one, you said that they are quite challenging to get the data from the business domains, like maybe from the medical domain, maybe like from the hospital or the service industry domain, like a hotel. So do you have any case study from your experience that to get this kind of data from such that domain?
Actually, currently one of our target is touristic domains. So now we are using guidebook written, published in Japan. So in Japan, there are very, very big travel agency, and they published the guidebook all over Japan. And also they have these English versions. So now we are creating the system to extract necessary information from such a tourist guidebook. And also we are trying to create a tourist guidebook machine translation system by training the parallel data of such guidebooks.
Okay, so much. Next one, talking about the ambiguities. For example, that you mentioned about the sentence, I saw the girl with the telescope. And from that ambiguity sentence, is it possible to apply those ambiguities to to educate the people about the psychological test or the people from the community classification, because different people group also have different mindsets or different perspective, and can we evaluate or can we observe from that ambiguity in that sentence?
Actually, current system, I say there are 4 ambiguities, but the current machine natural language processing system will extract only one result. So the sewing using the saw is, we don't use that kind of interpretation. And the problem is these 2 cases, saw with or girl with. But in this case, actually, probably so girl with is a first choice because girl with is much closer. I saw a girl with telescope and saw with a little bit far between saw and with. So in that case, it's not a rule, but it's some psychological things. So people will choose shorter context. So they will get a girl with sorry, I saw a girl with a telescope as a first choice. This kind of things is we can use.
Okay, next one, you're talking about the machine translation, right? And then nowadays, seem like so many people in the world, especially online, try to use like a public translation, like a Google translation. And sometimes once people input so complicated sentence, and sometimes again, the output from that translation is make a mistake, make errors. What do you think about to make that sentence as input like as simple as possible, like a sentence simplification?
Yeah, basically, the shorter sentence can be translated more properly. However, I showed you the example of neural machine translation. In that case, the first sentence and the second sentence translated differently for one proper nouns, location names. So in that case, if you divide the very small chunks to such a long sentence, so each part is handled separately. So it makes another problem, I think. So I think maybe there are some good lengths for machine translation. Maybe so say 30 word or something like that. Not smaller is better.
So smaller, shorter, and simpler is better, right, for translation?
Yes, smaller means there's no other information, no context. So the very small sentence is very difficult to translate. We need some information, but context or co-current information. So we need some length.
Okay, and we have additional question from the participant. They said that may I follow the question like, are there any specific characteristic of languages that can get the best translation result from each type of machine translation?
So for SMT, we need parallel text. So SMT itself is a very good way because it's based on it's word-to-word translations. So if two languages, input language and output language is similar in style, so SMT can be a very good result. So for say French and English, SMT is good, but the very different language, say Japanese and English, and maybe Thai and English. So in that case, neural machine translation is better because they understand whole sentence and output the sentence in the target languages.
Okay, next question from the participant. Can we fix the machine translation annotation error by feeding more data to the machine? Is it even possible to create a perfect machine translation in the future?
So yeah, we try to find the erroneous translations. We try several methods. So one is we change the input a bit and create the output. If the output is varied widely, so the translation can be error, so something like that. We use this kind of mechanisms to find the error, and this kind of, by using this kind of approach, we can fix at least we can find the erroneous part, and then manually fix the annotations. And even if we have such a big perfect parallel data, I think to create the perfect machine translation is very difficult, because even if one machine translation system is very good system, the problem is this machine translation system can use the information written in the text. However, to people, human translator use much more information than each sentence has. So such, say, common sense or something like that is very hard to handle machines. Theoretically, it's possible, but in reality, I don't think perfect empty system is not possible.
So we still have more questions sent privately to me. So okay, one more question is that nowadays seem like so many people try to using the social media, and then they likely to create a new word, a new terms that is not defined in the dictionary. So we may say like out of vocabulary, right? Do you have any suggestion in order to maintain the accuracy of the natural language processing because of that out of vocabulary problem?
For out of vocabulary things, there are two things. One is for NLP research, we will get for NLP research, so how to extract out of vocabulary terms. So we had a research on such areas. So we extract named entity from by using machine learning. So we had this kind of things, and this kind of approach. And several people do this kind of researches, and using the output of this kind of research, we'll get some new terms from new corpus. This is one thing. However, so new term is created daily. So say the term created yesterday, to get the such term to get yesterday is very difficult. So the second thing I should point out is this can be done by Google or Microsoft, because they have information retrieval system, the Google search, for example. So they check the terms user put into the use for searching things. So if one new thing of course it's out of vocabulary exists, so people put it into the Google search. So Google checks such things. Oh, must be the very new terms, and then they store this new term into their dictionary. So this can be done by only the companies which has a big share information retrieval systems. So in that sense, Google and Microsoft can extract such out of vocabulary new terms, but other industries other companies cannot do this kind of things.
Refers to the question in Thailand. We have like one institution that try to define especially the new term in Thai language. It's like a Royal Institute, and then sometimes it's quite delayed to define those new words. Do you have any recommends about the terms? Once we know that we got the new word, a new vocabulary, and then how long does it take for the institute or for the company to define that new term in order to let the people use in the right way?
I'm sorry, I can't get your
Okay.
point.
For example, in Thailand, we have like a Royal Institute that the official organization that try to define the meaning for the new terms or new vocabulary. But however, it quite takes some time to let everyone knows the definition formally. So we want to know that how long that it take, in your opinion, to announce or to define such a new term and to let people use it in the right way.
I think so. The meaning of word is defined by the people who use it. So at least in Japan, there's no such organization to define the meaning. Of course, there's a dictionary compilation company, a publisher exists, but it's just gather the meaning but which people use for each word. So they don't decide the word. So they don't want to control such meanings. So I'm not so sure. One thing I heard from, I'm an ISO member of Japanese ISO domestic committee member. So I heard from Chinese people that for China, so term definition is very simple. Once the country, once the government decides a meaning and decides a dictionary, so it's just a national standard. Everybody will follow that one. So it's very simple. But in Japan, we have no such things. We have National Institute of Japanese Language, but they don't do such things. I'm sorry, I don't understand your question, but I can say now it's like that.
Okay, thanks so much. For the participant, if you have the question, you can use Zoom to raise your hand and ask a question and turn on the microphone if you want to. And if you want to, I think we got one, right? I'm not sure. One guy raised the hand, right? Let me check.
Yes.
Yes. Okay, please
I would
ask.
like to ask the question, please. Okay,
Okay,
hi.
please ask.
Okay, I'm Natanat from King Mongkut University of Technology, Thonburi. I would like to ask about, you said that like using a deep learning for machine translation is like a black box operation, right? So how can, do you have any idea how to make it more like explainable or more transparent to the user, developer, like this? Thank you.
Yeah, I think I should, yeah. I think I'd like to do that, but so far I have no idea to make it transparent. So what I am doing personally is I accept such a neural machine translation system, and I add the peripheral systems that before machine translation and after machine translation, we add some mechanism to check the erroneous part or something like that. So actually, I don't have any idea to handle the inside of the neural network systems. So for transversal, yeah, I told you that such a thing is very important, but I have no idea about it.
Okay, next one. It's very good concept about the data sharing. Can you balance about the data sharing and data privacy for the natural language processing?
Can you balance?
Balance, because right now the concept of data sharing is very useful and important nowadays. But again, on the other side, they're talking about the data privacy, right?
Mm.
Can you balance about the sharing and privacy?
The privacy is very important things. One thing is now we have a discussion in ISO communities to handle such as privacies. And this is, I'm one of the member of that kind of discussions. So this is one thing that I can say. And for privacy is very important, but I think some part is we should consider severely, but other part we should not so too much focus on such things. So currently we are saying that for example, speech data, so every speech data has a privacy because speech data includes not only the textual information but also the tone or other and the characteristics of speech. So each speech is owned by each specific person data or something like that. I think it's not a good way for at least for for AI researches. So privacy we have to divide one thing. It's really important. It's his or her very privacy things. But the other part is we should make it freely.
And thank you so much. We got another question from the participants. Say that, could you explain more about annotation? Does it mean using size and color or other things also?
Annotation is there are several ways. For natural processing or for text processing, there is very basic annotation is to add morphological information. Like this one is noun, this one is verb, and this part is a noun phrase, and this part is a verb phrase. Such things is a very basic annotation for text corpus. This is one thing. And we can add much more metadata. Say this one is a question, this sentence is a question, or this sentence is say, this sentence is to complain other things, is this sentence is talking about this kind of issues or such things. So there are several kinds of annotations. It's very basic one is such a morphological or syntax one, and the very high level annotation is such intention or human behavior things. So as we are treating only the text database, so our annotation is something like that, not the color or sign. Of course, there are many annotations. So when we treat the data in general, so sometimes this picture is about the mountains, or this picture is about the ocean or something like that. Such kind of annotation is also possible.
We still have more questions. What do you think about NLP in next 5 years?
Yeah. Recently, I was asked somebody that this kind of things will be appear in 5 years or something like that. So my answer at that time is, 5 years later is I cannot imagine, because 5 years ago we have no neural machine translation systems. So probably very new things will happen in 3 years, I think.
Any more questions from the participants? Because right now, I think like I got several questions from us. But personally, I have one more question. You're talking about the data, AI data consortium, right?
Mm-hmm.
So it's mainly in Japan, right?
We are currently mainly in Japan, but we are now thinking to collaborate with another organizations outside of Japan. Now we just trying to do so.
And how about the ethics in the NLP? Because right now I heard that there are some group of people try to set up about the ethics in AI. How about the ethics in NLP especially?
That's a very difficult problem, I think. Because, for example, we are trying to my research part is a text processing. So even one sentence can be understood differently. So some people think this sentence is not proper, and other people think this is okay or something like that. So for speech, we have some intonation or such things to show our intentions, why we say this kind of things. But for text, all such things, or sometimes even context will be disappeared. So to handle this one tenses is okay or not okay is very difficult things. So still we have to divide several the problems into several parties. So in general, this can be not good, or this is in this context, this is good or something like that. So we have to think about this very carefully.
Wow, seems like we have so many challenges in NLP, right? And right now, I just post the Google form for everyone who joining our special online session today. It's about the learning experience sharing. So you guys can provide like what you have learned today, and then how can you apply the knowledge that you got in your own task? Because seems like so many people come from the university, come from the company, and come from the public government today. And while still we have time, so I would like to promote our upcoming activities next week also. So let me share this one to you guys here. Okay. So next week, again, we have another special sessions about the NLP. So the topic is about exploring a lexical with the adapting NLP technology for understanding human language by Professor Kyoko Kansaki from Otemon Gakuin University, Japan too. So next Wednesday, the same time from 2 p.m. until 4 p.m. in the Wednesday afternoon, Thailand time. And then what we will learn next week about again NLP and the lexicon, and how to build the lexicon by using the NLP technology. And we have like what a lexicon needs for the language understanding and generating. And finally, our professor gonna provide us about the case studies in the next week. Okay. And today, if you guys still have questions, please ask. But if not, because right now we have about 10 minutes left. So I think I would like to close this session. So thank you so much, Professor Isahara, for your kind participation and your kind providing us the useful knowledge in NLP. And we hope that this special lecture can inspire so many of us to continue do the research in the NLP to make our society better and better. So thank you so much for joining us today, and please take care and stay safe during the COVID-19 pandemic. So we have the online class like this. And again, we hope to see you again, especially in Phuket, Thailand.
Yeah, thank you very much.
Thank you very much. So I think that's all for today. So thank you so much for joining us today too. Bye bye.
Bye bye.
Thank you.